In the last lesson, we saw graphs for a function a to the power x when that base is greater than 1 and when that base is between 0 and 1. Now let's take a look at other values for a and talk about why they don't exist. If a equals 1, we would have the function 1 to the power x. Well, what would that look like? Well, if I start plugging in some numbers, f of 3, 1 to the power 3, 1 times 1 times 1 would be 1. F of 5, 1 to the power 5 would be 1. F of 0 would be 1. Are you seeing a pattern yet? F of negative 1 would be 1. The function's just 1. Well, that's not exponential. That's just the line y equals 1. That's a linear function, not an exponential function. So we have to ignore a equals 1 in exponential functions. It's not exponential. It's a linear function. What about if a is 0? Well, if we had a function 0 to the power x, starting out, we'll do 2. 0 squared is 0. 0 to the first power is 0. 0 to the 0 power is actually something that is called indeterminate. We can't decide whether this should be 0 or it should be 1. Should it be 0 because the base is 0, or should it be 1 because the exponent is 0? We would need calculus to figure this one out. So it's unknown for us right now. Also, if we look at negative exponents, 0 to the negative 1 would be 1 over 0. This is undefined. So we have this odd situation for 0 to the power x that we'll have a whole at 0. And then for all the positive exponents would have values. But notice this is another line. It's another line with a different domain and range than what we've just seen. So we don't talk about exponential functions with a base of 0. It's not exponential again. What about a negative base? Let's use negative 2 to the power x. Let's start out with some positive numbers. Positive numbers tend to play nicely at first. So negative 2 to the third power would be negative 8. If we square negative 2, we'll get positive 4. To the first power would be negative 2. To the 0 power would be 1. So far not too terrible, but these numbers are bouncing between positive and negative. That's weird. And then if we try to do negative values, won't be too awful. Negative 2 to the power negative 1 would be negative 1/2. But now here's where the problem comes in. If we start including rational exponents, if I look at h to the 1/2 power, for example, negative 2 to the 1/2 power, this is square root of negative 2. What did you learn about square roots of negative numbers? They are not real. So now we're jumping into this complex plane that we're not going to graph. We've got numbers that are bouncing all over the place. This is not a very nice function at all. These rational exponents, too, are scattered all throughout in between these whole numbers. So we're going to have so many holes and gaps in this function. It's just not worth talking about. So we throw out all of the possibilities for negative bases for exponential functions for that reason. These are just not very well behaved. When we're talking about exponential functions only occur for greater than 1 bases and between 0 and 1 bases. And those are the ones that we'll focus on.